Today is second day or last day of this sample size calculation online workshop, and today we will discuss which we have left yesterday, and along with today's topic. So we will do two groups if there are two groups, and the primary outcome is qualitative or categorical. So we have to calculate proportion. So we have to calculate sample size according to proportion, difference between two proportion, and difference between two means. And then sample size calculation in RCTs, and sample size calculation when medians are given instead of means. So sometimes in previous studies, we are not getting means. Okay, we are getting medians. So first we will convert this median and interquartile range or range into mean and standard deviation. Then we will calculate sample size, because there is, in my experience, in my view, there is no software or formula to calculate sample size calculation directly from median. Okay. Then sometimes we didn't calculate sample size, okay, in our study or research paper, and after that, after completing of or submitting our paper, we have to calculate. So we cannot calculate sample size, so we have to calculate power calculation. It's called post hoc power calculation. So how to do, we will discuss, and we will see or hands-on practice on some online calculators. So this is very important slide for calculation of the sample size, and there are like 4 points we have to remember always. That sample size must be calculated, you can say should be calculated. According to me, it's must be calculated on primary outcome. Okay, so our primary outcome must be clear. What is our primary outcome? It is quantitative type of primary outcome or qualitative or categorical type of primary outcome. So in quantitative, I have already discussed yesterday, that is systolic BP, okay, HB level, and scores like health related quality of life, depression, okay, depression in scores, mean depression, something like that. Okay, but in qualitative or categorical type, that is like mortality, yes and no, depression, yes and no, success, yes and no. Okay, so that is complication, yes and no. It is qualitative or categorical type. So for categorical type of, we have to calculate proportion, prevalence, incidence, something, and for quantitative, we have to calculate mean and standard deviation. And we should know power of study. So before calculating sample size, researchers has to decide power of study for sample size calculation. And here only two, like 80% power or 90% power. Either we use 80%, 90%, not less than 80%, no more than 90%. And confidence interval, please use on, I recommend 95%. No need to go 90 and 99%. There is no need, 95%. And this is table yesterday we have already discussed, but for sample size calculation in two groups or more than two groups, we need this table. We have to, and please write down, because we need these values during calculation of the sample size when we compare two group or RCT of two groups. Okay, so you have to remember this. If our power of study is 80%, here power of study 80%, okay, here power of study is 80%, so Z value is 0.842 or 0.84. Okay, you have to remember this. if our power of study is 90%, this is 90% here, you can see, and then our Z value is that is a Z beta or 1 minus beta, same thing. Z beta or Z1 minus beta, same thing. So our value, corresponding Z value is 1.28, 1.282 or 1.28. So you have to just remember, you can write down. Then, as I told you, it is alpha value, that is a type 1 error, beta is type 2 error, we know. So alpha at 5% level of significance, it means there is a 95% confidence interval. 5% means there is a 95% confidence interval. Alpha 5% means that is a level of significance, and its correspondence to 95% confidence interval. So here, if the test is like we are using design is one-sided. One-sided is only two in condition, superiority and inferiority. In other conditions, we use this two-sided. So please remember, if you are calculating sample size for superiority and inferiority trial, use this one-sided, okay? And this value is corresponding Z alpha value, 1 minus alpha or Z alpha is same, okay? That is 1.645. Please use this in superiority and non-inferiority. Please use this for Z alpha. But in other conditions, like we have done yesterday, in cross-sectional descriptive, in like a single group proportion, single group mean. Yeah. And today we will like discuss about two groups and randomized controlled trial of two groups. So this two-sided alpha by 2 value will come. Okay, we use this. So it is Z1 minus alpha by 2 or Z alpha by 2, same thing. And this value is 1.96. So please remember always this, okay? The 4 things, 1, 2, 3, and 4. Third one is 1.645 for superiority and inferiority trial. So for others, you have to remember these three values, 0.84 at 80%, 1.28 for 90%, and this is 1.96 for 95% two-sided. Okay, level of significance is like two-sided, that is a 2.5% each side. If you want to calculate sample size 80%, so you have to remember two values, 0.84 and 1.96. If you want to calculate sample size 90%, you have to remember two values, 1.28 and 1.96. So it's a simple things, okay? Now, sample size formula for two proportion, or we can say sample size calculation for comparison between two groups when endpoint or outcome is categorical or qualitative. Because we are talking about proportion. So proportion is in categorical or qualitative. Or we can say sample size calculation for RCTs, randomized controlled trial of two group with the categorical outcome. So for two group and RCT, the sample size formula is, you can see here, it is looking difficult for you, but one by one we will discuss, okay? So we can say here, it is because we are doing for two groups, so it is N2. When we calculate sample size, it is coming for, we can say N2, that is mainly for control. It is N2 means control group, okay? And then is equal to and greater than R plus 1 divided by R. You have to just remember this, multiply by, this is coming. So Z alpha by 2 or 1 minus alpha by 2, same thing. So we know value of Z alpha by 2. What is value of Z alpha by 2 or 1 minus alpha by 2? You can write down in chat, okay? Then plus Z beta. Z beta means Z1 minus beta. If we take 80% power, this will change, okay? And what is value of Z beta at 80%? We know. And what is Z beta or 1 minus beta? Same thing. 90% we know. Then what we have to do? We have to add both values and we have to square it. Then multiply by P, capital P, again multiply by 1 minus P. So P, 1 minus P, we have seen in, I think, yesterday. Okay, then divided by P1 minus P2 square whole square, you can see. So here you can see it is P and it is P1 and P2. Both are different. Okay, there is a difference between capital P and small p. It is P and it is P1 minus P2. You have to remember. So what is this? We can elaborate it. I will explain you. So you can see here R. So R is a ratio of control to cases. It is not cases to control. It is control to cases. It means control number of patients in control divided by number of patients in cases or intervention. So this is according to this. And R is equal to 1, we are taking for equal number of control and case or intervention. Usually we are taking equal number of, like in both group, we are taking equal number of patients, okay, in control group or in case or intervention group. If there is a change, we can change it and then we can calculate sample size. Then what is capital P? P is a average proportion exposed. Okay, so what is it? It is P1 plus P2 divided by 2. It is an average proportion exposed, means outcome of interest in control group plus outcome of interest in case, we can see, or intervention divided by 2. This is P. So when we see in example, we will calculate this. Z beta, I think we know about this. What is Z beta? So at power of 80%, it is 0.84. Power of 90%, it is 1.28. Please remember this. Z alpha by 2, we know very well. It is a 5% level of significance or 95% confidence interval. It is 1.96. Okay. And P1 minus P2. What is P1 minus P2? You can see it is P1 minus P2. Sometimes in you can when you Google or when you see other books or some other literature, you can see here it is a delta square. Okay, here P1 minus P2. Here you can see delta square. So what is delta? Or D square. Okay, D square. So that is difference or effect size, we can see. Okay, so P1 minus P2, effect size or difference in proportion exposed, expected based on previous studies. So we are taking it from previous studies. Okay, P1 is proportion in cases and P2 is proportion in control of that outcome of interest. We have to remember. Okay, I'll give one example for this before going to comparison of means. So I have taken one example for you. So this is two proportion. Okay, this is visible. My slide is visible. Can anyone? Yes, thank you. So this is formula. We have already discussed about this. Okay, so this is formula for sample size calculation for the comparison of two proportion or for RCT of two group with categorical outcome. Okay, so we have already discussed about this, all the things. So suppose what we are going to do, we are going to this. Okay, this is, we are going to this. In our study, okay, we are calculating, we want to calculate sample size. So according to previous study, you have to give reference. According to previous study, the prevalence of bed sore was in 50% of the patients with stroke at 3 months in control group. Okay, so for this we have to give reference. So what do you mean by P2? P2 is a 50% here at 3 months. So what is it? It is bed sore, prevalence of bed sore. Bed sore, yes, bed sore, no. That is a categorical or qualitative data. Okay. So in current study, we assumed or hypothesized that around 30% of the patient in intervention group developed bed sore at 3 months. So in control group, it is 50%. But in intervention group, we want it is only 30%. So here you can see 20% absolute reduction. You can see 50 minus 30, that is a 20%. So we want in our study that we want, or we hypothesized, or we assume that in intervention group, whatever is our intervention, okay. So in intervention group, we want bed sore, we want, because in intervention group, we want bed sore lesser compared to control group. We don't want prevalence of bed sore higher in experiment group, okay. So because bed sore is a negative thing, so we want to reduce it. Pain is a negative thing. Pain yes, pain no. So in control group, pain is, for example, 60% of the patients have pain, okay, according to previous study, due to any condition. So in intervention group, what is our hypothesis? We want reduction in prevalence of pain. We don't want there is an increase in, okay, because pain is a like a negative thing. But for positive thing, for example, success rate, okay, we want higher in a intervention group compared to control group, okay. So here 20% absolute reduction. Why we want reduction? Because bed sore is a negative thing. But if we want success rate in intervention group, so we can say 20% absolute increment. Or here in control group, if success rate is 50%, so what we want in intervention group? Below 50% or below 60%? No, we want success rate higher to compared to control group, okay. We want 70%, 80%, whatever. So here bed sore is a negative thing, so we want to decrement in. So you have to think about this. What is your primary outcome? And it is negative or positive, what you want. In negative, we want in decrement or reduction. Or for positive outcome, in intervention group, we always want increment or improvement, we can say. So here we have 30% in intervention group, prevalence, proportion or percentage, and here 50% in control group, okay. So we calculate sample size for this. So here, this is capital P. So what is capital P? This is the average of these two proportion in case or intervention or control group. So here this is P is equal to P1 plus P2 divided by 2. So here P1 is 30% or 0.30. You have to remember this. 30% or 0.30. 30% is in percentage and this is proportion. 0.30 is a proportion. And P2 is in a control group, 50%. So it is a 0.50. So we can calculate P. P is a 0.30 plus 0.50 divided by 2. It is coming 0.40. You can do calculations. Z beta, what is Z beta? So we know about Z beta. 80% power, it is 0.84, or 90% power, it is 1.28. So researchers, you have to select power for the study before calculating sample size, 80% or whether 90%. Okay, then what is Z alpha by 2? It is 1.96. Except superiority and inferiority trial, it is always 1.96. Remember this. At 95%, always take 95% confidence interval, or it is called 5% level of significance. What is P1 and minus P2? It is effect size, okay? Or difference in proportion, control and like experiment and control group. So it is, what is it? It is 0.50, the prevalence like control group, we can see. Control or experiment, we can see. So it is 0.20, something like that. Okay. So this is effect size. So we have to put all these values in our formula. Okay. We have to put all these values in this formula. I'll copy paste here. You can see here, we want R. R means equal sample size in control or experiment. So this is R is equal to 1. When we put here 1, so this is 1 plus 1 divided by 1. Okay. Then multiply by, this is Z alpha by 2. So we have decided we want 80% power of study. So it is 0.84. So you have to write down 0.84. This is Z beta. Okay, Z beta 0.84 and Z alpha by 2 or 1 minus alpha by 2, this is 1.96. Okay, we have to sum and we have to square it. Multiply by P, we have to calculate P here, already calculated. P is equal to 0.40. So we have to put here P 0.40 multiply by 1 minus 0.40. There is no issue. Then P1 minus P2, this is 0.2. If you think that it is P1 minus P2, it should come minus 0.20 because this is P1 minus P2. So it is 0.30 minus 0.50. So you can put it here minus. So no issue. I can put here minus. It is P1 minus P2. So in sample size, there is no problem. Okay. So here we have to put a minus. Okay. No issue. Because it is squared, so it will come positive. So there is no problem for this. Then what happened? Then again, this is, you can see here. Okay, you can see here. Okay, you can see here. So this is 2 divided by 1, multiply by all the things we have written here. It is minus. Okay, no problem. Then we can see here, we have to do this 1.96 plus 0.84. It is coming 2.8. You can do yourself. Then this is coming 1 minus 0.4. This is coming 0.60. And this is a minus. Okay. Then this is coming like the 2 multiply by, we have to square of, we have to do square of this 2.8. So it is coming 7.84. 0.40, then 0.60, and this is, we have to square also this minus 0.20. So it's coming 0.04. It's positive. Okay. Minus multiply by minus positive. Okay. So no issue. Then we have to calculate. This is this calculation is coming 3.7630 and it is divided by 0.40. It is coming 95. So N2 means R control group, but here N2 and N1 is equal. So in each group we have to recruit 95 patients. Okay, so total 190 patients we have to recruit. So we can write down according to this. Okay. So in current study, we assumed or hypothesized that around 30% or 20% absolute reduction of the patient with the stroke developed bed sore at 3 months in the intervention group. So in our study, we have to recruit 95 patients in each group, total 190 patients, to achieve 80% power of study with a 95% confidence interval. So we have to calculate sample size according to this. You can think about your research. If you have this type of 2 group or RCT with 2 group, okay, you can do. So for 3 group, what you have to do, you can take one, you have to calculate sample size for 2 groups. Okay, then you can add one more group here. So for 2 group, it is 95 in each group. So in 3 group, 95 in each group, 95 plus 95 plus 95. You can add and you can write down here for 3 group, 4 group, there is no problem. Okay, so we can for 2 group, 3 group, 4 group, 5 group, we can add here. So there is no problem at all. To achieve 80% power and 95% confidence interval. And if you want to calculate dropout or loss to follow-up, because it is a 3-month follow-up study, it is a stroke. So stroke may be severe. So you have to adjustment, you have to do adjustment for dropout also. So yesterday we have done, but you for dropout, you have to take this 190. Okay. For dropout, you have to take 190. And from 190, you have to calculate dropout rate. So how you can calculate? Okay. So here 190 patients. So for dropout, we have done yesterday. So I'll give demo again, no issue, adjustment for. So here you can see, here, okay, I want to do this. So here NB is a before adjustment. So what I have to write down? I want to write down 190. At 10%, okay. So I have to write down here 190. Then I have to calculate. So I have to calculate. It will come around 190 divided by 0.9. It is coming 211.11. It means it is coming 212. So with the 10% dropout, the researcher had to recruit total patient 212 and each group 106 in each group. Okay. In each group, you have to write down 106 patient or participants. You have to bracket it. And you can copy paste it. There is no problem. Okay, you can copy paste it. Where is your? This is here. So then you can copy paste it. So what you have to? You have to recruit 212 patients. Without adjustment, you have to recruit just 190 patients. But after adjustment, you have to recruit 212 in total. So in two groups, so in each group, we have to divide this 212 divided by 2. So it is coming 106 patient. It is 10% dropout. You can take 20%, 5%, and 30%. So this is formula to do. Okay. So what we have to do, we can do according to this. So this is for proportion. Okay. We will do same thing in online calculator also, but before going to that, we will discuss about two group mean comparison. It is a categorical outcome, for categorical outcome, and like mean comparison, that is a quantitative outcome, numerical outcomes. It is a proportion, that is a mean. You have to just remember this. Okay, so I'll cross it. I want to save. Okay, I can save it, no issue. So I have already opened, no problem. It is coming for. If you practice 1, 2, 3 times, the formula will be very easy. You can calculate manually, and then you can use like online software. So this is sample size formula for two means, or formula for sample size calculation for comparison between two group when endpoint or outcome is quantitative or continuous or numerical, you can say. Or sample size calculation for RCTs, randomized control trial of two groups with quantitative outcome, continuous outcome. Okay, when we compare two means. So this is sample size. It is something like similar to like that previous one. So we will discuss first this, and then we'll go to hands-on practice, like with one example, then hands-on practice. Okay. So it is again n by 2. N by 2 means always you have to think this is for control, n2. So we are calculating sample size for control. But if control and experiment are equal, then we can use this calculated sample size for intervention also, or case also. Okay. So same, what is R? You can see here, this is same thing. Z alpha by 2 plus z beta square multiply by, this is sigma 1 square, that is a standard deviation of group 1 chi square, plus standard deviation of group 2, this is 2 and group 2 chi square, divided by r, and this is divided by mu1 minus mu2. This is a mean of group 1 minus mean of group 2, and it is a whole square. What is R? We have already discussed. For when case or control are equal in number, then we are using R is equal to 1. What is Z beta? We know. What is Z alpha by 2? We know. What is mu1? This is the expected mean of outcome in group 1. So researcher can take value from previously published studies. Okay. And then they can take from pilot study. If they didn't found any previous study, they can take their clinical experience, okay, expert opinion, or they can assume whatever. Mu2 is expected mean of the outcome in group 2, and sigma 1 is expected standard deviation of the outcome in group 1. We can take as we are taking for mean also, previous study, pilot study, experience, assumption, whatever. And sigma 2 is expected standard deviation of the outcome in group 2 also. Okay. So for this, there is one this is for 2 mean. Okay. So this is formula for sample size calculation for the comparison of 2 means or for RCTs of 2 groups with quantitative or continuous outcome. So this is formula you can see here. We have already discussed. So we have already discussed. This time we will take 90% power of study. That is value is 1.28. Okay. So Z beta will come here 1.28. Z alpha by 2 always 1.96. Okay. Mu1, we have taken one example. It is coming 52.32 in expected mean of outcome in group 1, and mu2 expected mean of outcome in group 2. It is coming like I have taken from previous study. I'll show you this previous study, no problem. Sigma 1 is expected standard deviation of the outcome in group 1, that is 8.87, and expected standard deviation of the outcome in group 2, that is 10.07. We can see here, okay, we can see here sample size calculation. Then we will do. The sample size for this study was calculated. I have taken from previous study. I'll show you published study. The sample size calculation for this study was calculated based on Mohammadi et al. Study, and I have given reference here. Okay, this is reference. Always we have to give reference. According to alpha is equal to, we are taking 0.05 and power of study 90%. And using in this study, they have given pre-test and post-test mean and standard deviation of the self-efficacy score. This is a mean of a self-efficacy score in the study of Mohammadi et al. So this is pre-test mean. We can say it is a control group mean. Okay. So 52.32 plus minus 8.87. So it is 52.32 is a mean, plus minus this is a standard deviation. This is mu1, this is a sigma 1. And this is for experiment group or intervention group. 59.45 plus minus 10.07. Although in this study they have given post-test mean, but here we are using this for intervention study because it is coming after intervention. Okay. So 59.45 plus minus 10.07. We have already given reference. So I think by mistake I have written here. So we have calculated this sample size. Okay. So what we have to do? We have to, I want to show only this thing to you. Okay. Only this thing. Alpha is equal to this itna and this itna. Okay. So you have to remember this. 52 we have written down over there. So now what is our formula? I have again copied this formula from here to here. Okay, no issue. So I can copy this formula. So this is formula. We can see N2 equal to and greater than. Please use always equal to and greater than Z alpha by 2, 1 minus alpha by 2. It's same thing, plus Z 1 minus beta or Z beta whole square multiply by these things. Okay, and divided by difference of means whole square. Okay, so we are using Z alpha by 2. We know what is Z alpha by 2 value at 95%. We have to write down 1.96 plus what is Z beta we are using for 90% power of study. It is 1.28. So I have to write down 1.28. Multiply by this is sigma 1, group 1 standard deviation. So what is group 1 standard deviation? 8.87. So please, this is 8.87 plus this is R because we have taken R is equal to 1. Okay, so this is sigma 2. This is, you can see here, sigma 2. We can see here that this is 10.07. 10.07 divided by 1. Then it is mu 1. This is mu 1, 52.32. And this is mu 2, 59.45. You can see here, we have written all the things. Then we have to do mathematical calculation here. We have to add all things. Then when like we squared it 8.87, it is coming like this. You can write down even like by 2 decimals here, no issue. So it is 78.6769. So we can write down 68. And it is 101.40. We can write down like this. So no issue. Okay. Then this, because it is coming minus, we can see 7.13 minus, no issue, because it like when we minus and multiply by minus, it's come like always come positive. So when we do it, you can see here, or otherwise I can click this. Okay, so this is coming 10.49. I can say here 10.49. So it is coming 50. I can write down here. And it is 1.18. I can write down this one. And this is 50.8369. I can write down 84. So no issue. Okay, so you can understand this. This is a 3.24 square is 10.50. It is when we add these two things, it is coming like this. Okay, and this is like square of 7.13 or minus 7.13. It is coming 50.84. Then we have to multiply these two things. Then this will come. And again, I can write down here. Okay, then again, I can write down here. So this is coming like this. Okay, 37.186. It is coming 38. So in N2 means this is a control group. Okay, so here N2 is equal to N1, we know. So in each group, we have to recruit 38 patients, total 76 patients. So we can write down according to this. So the minimum sample size, we can take it as a 40 also, there is no problem. 45 we can take, but that minimum sample size, we cannot take less than 38. Okay, remember this. We cannot take 37. We can take 40, no problem. Okay, so at 38 subject for each group, total 176 patients. To increase power and consideration, because when we increase sample size, power of study is also increasing. And considering the possibility of loss to follow-up, that number will raise to 45 subjects in each group. Okay, so in study, they have taken, authors have taken 45 subjects in each group. And but this calculation I did. Okay, I did according to this, anticipating a 15% loss to follow-up. We have to recruit 45 patients in each group, a total of 90 patients. Because here we are not seeing that how much loss to follow-up they are using. But here I calculated with the 15% loss to follow-up. Okay, so when we calculate with 15% loss, please calculate this. Okay, this is for you. So this is, and if we want to calculate for more than 2 groups, we can take 45, 45, and 45. For example, 3 groups. So we can take, no issue. Okay, 45 in each group. If are three group and 4 group, we can take, no issue. Okay, then this is for, and then I will show this paper. So this is from where I think this is paper, sample size two group mean comparison. Okay, so I think I have taken this from this paper. You can see here, it is a randomized control trial. Okay, this is effect of peer education based on Pender's health promotion model on quality of life, stress management, and self-efficacy of the patient. So they have taken primary outcome as a self-efficacy, and they calculated sample size on the basis of this self-efficacy score. Okay, so we have to know this. Then this is sample size calculation I have taken from here. And you can see here, this is formula they have given. Okay, they have given this formula here. You can see they have given this formula, but what they have done, they have used just a sigma square. And what we have to use? We have to use sigma 1 square plus sigma 2 square. You can see in our demo, sigma 1 square plus sigma 2 square, because we have taken r is equal to 1. So please remember this. Okay, so we have calculated according to this, and you can see what the sample size are coming. They are coming 38. Okay, and they have taken 45. So by step by step, we have calculated sample size in this. You can see here, they have taken power of study as 90%. Okay, there is a power of study as 90% they have taken. So you can see here, step by step, we can calculate sample size for this, and it is coming exactly at 38. And in this is also 38. It is a randomized control trial. And this is published in BMC Neurology. It's a very good journal, BMC Neurology. So we have calculated the sample size giving this example. Okay, so you can see here. And for two proportion, yeah, this is for two group mean comparison, two proportion sample size calculation. Okay, two proportion sample size calculation. So what? Okay, this is also Optibra study, a randomized control trial on optimum post-operative bra support after breast cancer surgery. Okay, this is published in European Journal of Oncology Nursing. And this is here, they have given sample size calculation. Okay, they have given sample size calculation. I think here they have given sample size calculation. Yes. It is very good thing. So you can see here in statistical method, they have written the sample size was calculated based on the primary outcome breast pain. So as I told you, sample size must be based on your primary outcome, that is a breast pain. We expected about 60% of the patient using a SB to report some degree of pain, that is NRS greater than 3. So if the patient having NRS numerical rating scale or score is greater than 3, they are giving that it is a pain. If NRS is 3 and less than 3, it means there is no pain. Okay, they have categorized into pain and no pain. 3 weeks after surgery, okay, to be able to detect a 20% reduction in experiment arm. This is experiment arm SBWC. Using a two-sided significance level of 5%, always take two-sided, power of 80%, we estimated that the study needed to recruit a total of 194 patients. The final sample size was set to 200 because they calculated 194. They took in round figure 200. So we can take more than, but we cannot take 190. Always we have to take more than the sample size if we want to take. Otherwise, we can take 194 patients. total 194 patients. So in each group or total they have taken 200 patients. So in each group 100 patients they have taken. Okay. So what you have to do? You have to, this is proportion or mean comparison. First, we have to think about this. This is a comparison of proportion between two groups. It is a, SB is a control group and experiment group is a, you can see here, SBWC. Okay. So it is a 60% patients having pain at 3 weeks after surgery in control group. SB is a control group. And you can see, because pain is a negative thing, so we want reduction. We want reduction, and in this study, they want reduction, a 20% reduction. So in experiment group, what will be 60 minus 20? It is 40% in experiment arm. So proportion of pain or prevalence of pain or percentage of pain in experiment arm, it will be 40% after 3 weeks. And in control group, it is 60%. So you have to think it is for proportion comparison to group or mean comparison. You have to think and you have to apply this formula. Okay, we will apply, no issue. So if I go online and this offline, both we can do. Okay, it is for you. Please, you calculate. So I'll give, this is for mean comparison. I will take proportion comparison. It is very, very good example. Okay, then we will go for online calculators. So this is 2 proportion. Okay. Oh, sorry. I want to copy paste. I want to save this file. Okay, so I can use this. So here P1 is for control, it is 60%. So it is 0.6, and P2, it is a 20% reduction. Okay, sorry, P1 is for intervention. So I can say P2 is 60%. Okay, you have to remember it is 0.6. But in P1, it is a 20% reduction. So what will be P1? 60 minus 20, that is a 40%. It is absolute reduction. It is not a relative reduction. Okay, so it is coming 40. So it is coming 40. So what we have to do? We have to put these values here. 40, 60. So it is coming 1. Okay, I think it is coming 1.00. So it is coming 0.50. Yes, very good. So what is P? P is a 50. If I did any mistake, you can check me or interrupt me. You can chat with me, no issue. So it is P1. And what is 80% power? Okay, very good. So in example, we have already taken 80% power. So all the things are similar, but what we have to do? We have to do here. This is similar. This is 40%. This is 50. You can see here, this is coming again coming 50. Then this is P1 minus P2. So it is coming like this, minus 0.20. Very good. Okay. This is P1 means 40%, 0.40 minus P2 is 60%, 0.60. It is coming. So here we can write down here 40 and 60. Okay. So it is minus 0.20. Then again, it is coming similar. Very good. No issue. So problem is like here. So we have to change only this thing. Then we can calculate sample size. So it is 50. It is again 50. 1 minus 50. It is coming 50. So all the things are same, but the difference only here. So it is very simple to calculate sample size for 2 group or even more than 2 group. Oh, very good. Then I have to calculate this. Okay, so I have to use my calculator. What I have to do? I have to multiply 2 multiply by 7.84 multiply by 0.5 multiply by 0.5. So it is coming 3.92. 92. Then divided by 0.04. So it is coming exactly 98. Okay. In each group, you have to write down in each group. So it is coming 98. So I can take 98. So it is coming 98. Total. Okay. In each group, 98. So total is 196. So what is over there? Okay, 194. So it's okay, no issue. So we are more than like 194. So it's coming similar. 2 and 4 and 5, it's like in calculation, there might be 2 and 4 number, maybe plus and minus. So we are very happy that we are coming 198. Okay, 196. Sorry. So they have taken 200 patients. So we can take according to this. So we can calculate sample size according to this. It's very easy. So we have to change this. So according to this. So we have to change this. Okay. So this is for this. And with online calculators, now we have to use online calculators. Okay. So one is API info, like Open API, very good online software to calculate for the calculation of the sample size. So for this example, we will calculate. So, okay, so I have to open this Open API. So you have to, in Google, you have to click. Yesterday we have done for single proportion. So I have to click Open API. It is coming Open API. Okay. Then I have to click this. Then I have to click Open API menu. Okay. So I have to click this. Then where is sample size? This is sample size. Here you can see sample size. So this is for cohort or RCT. Okay, this is for cohort and RCT. In like Open API proportion, this is the mean difference of two groups here. But right now we want proportion difference. So I have to click this cohort. So it is coming. I think it will take time. Okay, while it's opening, we can do, sometimes it will take time. We can have examples. Oh, mean and SD I have given already. For this I have given already. So what will be left from medians? Okay, so we will do from medians. Okay, okay. I want to complete it first. It will take some time. Otherwise, what I have to do, I can open another software, Statulator. Okay, this is also Statulator. Then this is coming window, and I have to click a sample size here. Then in sample size, you can see here Statulator, sample size, descriptive, statistical test. So I have to click sample size, and this is comparison of two independent proportions. So click here, compare two independent proportions. So please click here, this will come. Okay, so in our reference group, this will come, okay, in two independent proportion. What about, oh, it is going on, no issue. So in this example, we can see this example. It is 60% in reference category or control group, 40% in experiment. We can select it here. So in reference or control, it is a 60%. So we can drag. We can bring our cursor here, then we can drag it. You can see there is changing value. So it is 0.6. 60% means 0.6. Okay, I have set. I want to see here. Okay, it's opening, no issue. Then in proportion test group or intervention group, it is 40%. So I have to drag it. It is 0.35. I have to drag it up to 40%. 20% reduction you can see here. Then there is a option. So if you want, okay, please calculate sample size. So before you can click here, it is coming 104. But it is coming with the continuity corrections. So what is continuity corrections? No need to do. If they are assuming that if there is any error by continuity corrections, they are removing that error. Okay. Generally, we are not using this continuity correction. So what we have to do, we have to click option here. You can see here, this is the option. I want to see, okay, this is coming. We will calculate sample size using OpenAPI also. So, but first we will do with the statulator. Then I have to click option. When we click option, okay, then power is 80%. If I want to change it 90%, I have to click this. Then I have to drag till 90. Okay, but I don't want this because it is calculated for 80%, 90. But I don't want. So click close. Then two-sided, this is two-sided. Group size is equal. If I want to change is like 2 and 3. This is ratio of reference to test group. This is always for control to intervention group. Okay. So you have to think about this. If I want to take like change one-sided and two-sided, I can change it. So it is default two-sided, always take two-sided. If I want to change level of significance, I want to change like 1% or 0.1, I can change here, from here to here, I can change. But I don't want to change this, okay? All these default setting, but I want to adjust, I have to click adjust. So this is apply continuity correction. I don't want to apply continuity correction. So I click this, okay, then update. So it is coming 95. So total, and you can download it, you can copy paste it. So no need to write what I have to write down in like sample size calculation. You can download it and you can edit it. Okay, it is very good. All results and live interpretation you can see. So you can hear it's a 95%, 95 patients in each group. Okay, you can see here for each group, it's a total sample size of 190. For assuming equal group sizes. And this is a 20% reduction, you can see, with 80% power. All the things with two-sided p-value of 0.05. All the things you can here, you can copy paste it with reference. Please use reference because the authors or who made this calculator did great job for us. They made our life very easy. We can copy paste it. Select and copy. Okay, we can use for our paper, research paper, dissertation. So it's very easy. Okay, so we have to do. If I want to there is a dropout rate, so I have to click adjust and adjust for response rate. It is called adjust for response rate. No need to do adjust for clustering. It is always one. So adjust for response rate. Click here. Then I can anticipated response rate 60%. It means 40% is dropout, but it is not. I want only 10% dropout. So it is response rate is 90%. If 10% drop rate is loss to follow-up rate, it means response rate is 90%. So update it, you will get 105 rather than 95. So this is 210 samples. You can take this. So according to this, you can adjust. Okay. If you want to do sample size, non-inferiority and superiority and equivalence style, you can do using this. But this is like beyond the scope of this workshop. We will do a later workshop about non-inferiority, inferiority, and superiority trial. Okay. So this is equality for equality. Yeah, you can visualize these results using this This is expected outcome. This is a number. You can see, you have to see. You can tabulate this. This is a number of participant you have to recruit for your study. You have to read these things, but main thing, we have to use this. Okay, then if I want to use OpenAPI, so how I use? Okay, I click OpenAPI. In OpenAPI, there is some difference to enter data. So I have to click where I clicked in sample size, and then cohort or RCT. I clicked here. Okay, for proportion. So click enter new data. This is new data. This is a two-sided confidence level. This is 95%. Usually we are taking 95% here. Beta, it's 80%, usually 80% we have, and in this study they have taken 80%. This is ratio of this is you have to see here. This is okay. For equal samples, we are using 1. This is a ratio of unexposed to exposed. Unexposed means control group. Please remember, unexposed means control group. Oh, sorry. What is it? Ratio of unexposed to exposed group means unexposed means control group, exposed means intervention group. We are exposing the subjects with intervention. Unexposed is control group and exposed is intervention group. It is always taken 1 for equal samples. Percentage of unexposed with outcome between 0.0 to 0.99.9 we have to enter. Over there we entered 0.60, but here we have to enter actual value in percentage. So a percentage of unexposed with outcome. So what is that? Is 60%. Unexposed means control group. With outcome, what is the patients having more than number of patients or proportion of patients or percentage of patients in control group having more than 3 NRS. How many patients? This is a 60%. So we have to write down 60 here. Then please fill in one of the following. Other will be calculated automatically. So we have this. We don't have odds ratio. We don't have risk ratio. We don't have risk or prevalence difference. We just have percentage of exposed with outcome. So what is percentage of exposed mean? This is a control. This is a intervention group. And with outcome, how many patients? 20% reduction. It means it is coming 40. How many patients have some degree of NRS greater than 3 in experiment group? That is a 20% reduction compared to a control group. So it is 40. Okay. So you have to fill all these things. And then you have to calculate here. You have to, this is a button for calculation. You have to calculate. This is coming. So you can take say it is and this is also FLEACE with continuity correction. This is continuity correction. Generally, we don't need continuity correction. So it is FALSE with the non-continuity correction. It is coming 95. And CalSay, it is coming, this is a FLEACE and this is a CalSay. It is 96. So please, I recommend, please don't use this less number, 190. 192 is a more number. So please go for this. No need to go for continuity correction for our sample size. If you want to go, you can go. But I don't recommend this for continuity correction. So take this CalSay 96. In each group, total 192 you can take. You can do for adjustment for dropout. Okay. So in sample, in here, this is a 194. Okay. 194 total 200 patients. And when what we have calculated, it is 192. So it is very good. Okay. We can 192, then we can take 200 patients, something. Always take 4 and 5 extra patients. So no issue. Okay. So this is for how to use OpenAPI and how to use this statulator. So for mean, I will show how to do for statulator and how to do for OpenAPI with OpenAPI. So what I have to do, I have to click sample size here, then compare two independent means. Okay, then click two independent means here. This will come. It is expected mean. We have to choose, select one of two options to specify input values. However, the sign to obtain, you can take help of this sign. So I have to take this expected mean. Okay, when I click this expected mean, what I have to do, I have to do for mean of the reference group, mean of the test group. Mean of the reference group, this is for control. Mean of the test group, this is for experiment group. And here you can see this is only for standard deviation. It is not coming group 1 standard deviation or group 2 standard deviation. It is called pooled standard deviation. So here, first we have to calculate pooled standard deviation. We can calculate pooled standard deviation using online calculators. Otherwise, shortcut, what we can do, okay, I'll show you. For this standard deviation, where is our example? Two means. So this is for, I think this is for, yeah, this is two group mean comparison sample size, okay? So this is same. Okay, same study, okay? So where is, this is, if it not, okay, yeah, it is, I think, visible. We have taken 90% power. Please remember, this time we have taken 90%. So this is for control. This is for experiment. If you are getting only one standard deviation, so please always take standard deviation of which is more. So which is greater, you have to take. So it is standard deviation 8.87 and it is 10.07. So please take this greater standard deviation. Less, okay, please don't take this small standard deviation. Take large standard deviation. I recommend this, okay? Because if we take this standard deviation, we will get sample size some less number. If we are taking this standard deviation, then we are getting, we will get sample size, some more sample size compared to this, large sample size compared to this. So please always go for large sample size. Don't go for a small sample size. So take this, okay? So this is, okay. Then I use this here, okay. So mean of the reference group. What is mean of the reference group? I have to type here 52.32. Mean of the test group, I have to type here 59.45. Then standard deviation, so I will go for this 10.07. Okay. Then I have to click calculate. Then I can adjust for this. Okay. When I click adjust, calculate, so this will come 32. Okay, this is 32. And what we calculated? We calculated 38. So it means like if we are calculating using that, we can get. But this is, you can see here, this is for 80% power. But here, what is? It is for 90% power. When we increase power, sample size automatically will increase. Okay. So we have to go in option here, then change desired power. I have to click change. Then I have to go for 90. I have to drag it up to 90, 0.9. This is a 90%. And update, it is coming 42. Okay, it is coming 42. When we use 10.07, it's called pooled standard deviation. It means what it is assumed, in both group, it is a 10.07, 10.07 standard deviation in both group. Okay, so it is, I think, limitation of this statute, I can say here. Okay, but if I take this group, what is it? It is 8.87. Suppose if I take this 8.87, so what will be sample size? I have to click this 8.87. So what will be sample size? It is coming 25 with 80% of power. So I have to click option. Then I have to again increase power. This is 90%. Okay. Then update. It is coming only 33. If I use this, if I use that 10 standard deviation, it is coming 42. And if I use this 8.87, it is coming 33. So always go for larger sample size. Don't take this 33. So this is, I can say it is a limitation of this statulator. We cannot fill standard deviation of both groups. But in OpenAPI, we can fill standard deviation of both groups. So what will happen with this? Okay, click this OpenAPI. Again, go for sample size, then mean difference. Okay, so click mean difference here. So I can say, okay, it will take time. Sometimes it will take, okay, wait. So we can calculate sample size. Okay, I'll show with the OpenAPI. So OpenAPI, none of the online calculator have all the things. So sometimes you have to go for this calculator, sometimes you have to go for this calculator, and other like software like SPSS, R, Stata, Medcalc, they have option how to calculate sample size. So you can, if you have Stata, R, and Medcalc, GraphPad Prisma, and like SPSS, you can calculate sample size using those software also. But main thing, you have to know about the basics of how to calculate what the values we have to use for this. So I think this is take some time. Might be due to problem with this. Okay. One more software I want to show with the Clinic Calc. So use all the software. Clean Calc, sample size calculators. So this is sample size calculator, Clean Calc. You have to click this. Oh, this is coming like this. This is more sophisticated. Okay. So for which we have to calculate it, we want to calculate sample size, we have to calculate for two group mean, comparison of two group mean. So we have to select here two independent group, and this is for dichotomous, means Bedsore yes, Bedsore no, pass, fail. Okay, okay, it came here. Okay, so first we will go for OpenAPI, then we will go for Clinic Calc. So I have to enter data. So what I have to do, I have to enter new data here. This is 95%, power 80%, but here what is power? They have taken 90%. So I have to click 90 here. Okay, 90%. So I have to click 90. This time 0.990. Ratio of group size, group 2 divided by group 1, it is 1. Okay, always. Then we have to enter mean and standard deviation. We can enter separately standard deviation here for both group. So for this, I have to click this. Then I have to see this 52.32. You can, and 52.32, 8.87 for standard deviation. Okay, group 1. Then for group 2, it is 59.45 and 10.07. You can enter this value 59.45, 10.07 here also in group 1. It is okay. Same result will come. So then after entering this, if you have only mean difference, you can just enter here mean difference. Okay. In the experiment group, suppose this is control group 52.32. This is self-efficacy score. Okay, so we want self-efficacy score. You can see here, this is a self-efficacy score. Okay, so we want self-efficacy score higher in experiment group compared to control group. So I want, for example, 5 points higher score. So I can, like here, I can write down here only difference of 5, no issue. Then click calculate. This will come 38 in each group. 76, you can see. Okay, I have written 78. So this is 38 subject for each group to increase. Okay, you can see here, minimum sample size of 38. So you can see here, exact 38 we got. And total sample size 76. You can see here. And this is a mean difference, 7.13. By formula, by hand, we have calculated this also. No? So this is 38, 38, this is a 70. And when you do with the static calc, there is a limitation because you have only standard deviation of pool standard deviation. So from these both group standard deviation, there is online calculator. You can calculate manually pooled standard deviation. Then you have to put pooled standard deviation here. Okay, you cannot put only single standard deviation. Okay, so with the clinic calc, okay, so I think I hope that you understood this. So it is a two group independent study group, and this is a dichotomous, yes, no, or continuous. So we know primary endpoint is a primary outcome is a continuous mean. So I have to click this. So when we click this, you can see this will change automatically. So when I click this will change. Okay. And you can see here, this is also have only one standard deviation, that is group 1. That is for only control group, not for group 2, that is a intervention group. So this is also have some limitation. So if we enter this only one standard deviation of group 1, that is for experiment control group 8.87, this sample size will reduce. So we can see here. So OpenEPI is very good. I think OpenEPI is very good because it has standard deviation control group as well as for experiment group. So group 1 mean is 52.32 and plus minus standard deviation 8.87, and group 2 like mean is 59.45. Then it is for 90%, so I can increase power from here. This is a power 90%. I can increase. This is 90%. Enrollment ratio 1 means control and experiment equal. Then click calculate. This is alpha is 0.05. It's okay. When I calculate it, you will get sample size here. Okay, where is I'm not getting. This is calculate sample size. It is coming 36, 33 in each group, 33 in each group. Why it's less? Because we use this only standard deviation 8.87. So this software has a limitation also because we cannot enter both standard deviation, but OpenEPI is very good. Exact sample size we got it. Okay. So now for 5 minutes, if we have for example, if we have median, but we don't have from previous studies, we have median only. We don't have mean and SD. And we know that for medians, there is no formula to calculate sample size. So first, before calculating sample size from medians, we have to convert these median and interquartile range into mean and standard deviation. Okay, so I'll show you how we can calculate. So this is sample size from median. I have done for resident, one resident. So you can see here, example 1, sample size calculation when median and IQR are given instead of mean and SD. So according to previous study, median time to first rescue analgesia, I think it's for anesthesia, I think department resident, was 12 hours. 12 IQR is 18 to 16 hours in 70 patients of control group. This is, we have to give reference according to previous study. So we have to give reference here. For sample size calculation, we converted this median and IQR into mean and SD, and we got this using this Luo et al. And Won et al. 2014 and 2018 estimation, and this is link for how to calculate, how to calculate this. So click control. When I click this, so this will open. I'll show how to do this. then you can do. Yes. So if scenario one, if we have size of the sample, minimum of sample, median of sample, and maximum of sample, okay? And in scenario two, size of the sample, first quartile of the sample, median of the sample, third quartile of the sample. And in scenario three, if we have all the things, sample size, minimum of the sample, first quartile, median of the sample, third quartile, maximum of the sample. But what condition we have to, scenario we have to use? So what we have to see in this? So we have median and IQR. IQR means first quartile and third quartile. So this is 8 is first quartile, interquartile range. Okay, so this is 8 is first quartile and 16 is third quartile. So what we have to do? We have to enter data here. So I like, okay, here I can see. So which scenario will like fit for this? Scenario one? No, we don't have minimum. We have median, we have sample size, but we don't have maximum. But we have sample size, first quartile we have, median we have third quartile. So this scenario will use, okay? We will use this scenario. So this is sample size is 70, already given in previous. First quartile is, you can see here, it is, first quartile is 8, median 12, third is 16. So first quartile 8, median 12, and that is 18, third quartile. Then calculate. So estimation mean sample from Lau et al., estimated standard deviation from Wan et al. So click, if you want to detect the skewness, you can detect, but I'll omit it for this like calculation. Then click, this is coming, estimation mean is 12.70. You can see this is 12.70. It is coming like that. So I have to click this, and this is coming 7.50. This is mean and SD. So I have to write down 7.56. If I want to click detect the skewness, oh, 1 minute. This is coming 16. Sorry, it is third quartile is 16. Then I have to calculate. So it is coming like 12. Okay, you can see here, this is 12 mean, and this is median 6.05 or 6.06, you can write. So if you have median and interquartile, using this reference, I will send you in group. You can use, and you, according to scenario, you can fit, and you can like convert it into mean and SD. After that, what we do? After that, what we do? We hypothesize that in intervention group, mean time to first rescue analysis would be 18 hours in first, like in first rescue in intervention group. In our study, we have to recruit 22 patients. Okay, so for this, we have only one standard deviation. Okay, so we can calculate, because we don't have standard deviation in intervention group. So we have only standard deviation group of 1, that is a control group. We can use this standard deviation for both group to calculate sample size. So we can do using this like this clinic calc we can use. So it is coming, mean is 12 and standard deviation is 0.605. Then here group 2, it is coming, we have hypothesized it would be increased, because time to first rescue analgesia, if we increase it, it is very good thing, okay, for surgery. So the anesthesia like residents or doctors, they can know better than me. So this is, and it is for how much power? It is 90% power. Very good. So I have to select 90% already selected, equal, then calculate. This is coming 21 in each group. So here we have to recruit 22 patients in each group. So it's very good, 22 patients. The study will be designed to recruit 50 total patients. We can take with the allowed dropout rate is with 5%. So please calculate this. I have given you formula. Please calculate, and you can write down this also. So I have told you how to, I have explained you how to calculate sample size if you have only median and interquartile range, even range, okay, minimum, maximum, even 5 scenario, third, that is all 5 things. Okay. Now, last thing, that is, we did not calculate sample size before the study, but when we sent, we just assume, okay, we will take this sample size, and we took that sample size without sample size calculation. We submitted our thesis. Examiner can point out it, please calculate. But you have done your research study, you have submitted, so now you cannot calculate. So they like point out that kindly do post hoc power calculations. So like what you have group 1 mean, okay, group 2 mean, and that p value. You have already, you have taken sample size in group 1 and group 2. You have sample size for that also. So for this, what we have to do, we have to do power calculation. Okay, so for power calculation, what we have to do, we have to use our Open API. It's a very good tool to calculate power calculation. Okay, so it is last. I think I will take only 5 minutes for this. Then we will go for question answer session. So power calculation. This is Open API. It is very good software. Please use this. Okay. Then this is power. Okay. This is for sample size calculation. This is for power. So click here, power. Then if for this unmatched case control, cohort, clinical trial, x-sectional, and mean difference. So for example, I have done study. I didn't calculate any sample size for this. I can take this study, okay? I can take this study. Self-efficacy score. I want to take physical, psychological, and this is self-efficacy, okay? This is comparison of the self-efficacy different time point among groups. So at 3 months, suppose this is my primary outcome. At 3 months, this is my primary outcome. So I have enrolled. I think I have to see this graph. So analysis, I have done n is equal to 45 in control group, intervention group, and n is equal to 45 for control group. You can see here, this is a control group. Excluded from the analysis, n is equal to 0. So there is no loss to follow up. Here also there is no loss to follow. So n1 is 45, n2 is 45. Okay. So we have n1 and n2. Suppose for this we didn't calculate sample size earlier. So we have to do post hoc power calculation. So we have no what is N1 and L2, and this is our primary outcome, self-efficacy, suppose. And I want to calculate it 3 months after intervention. This is our intervention group self-efficacy, mean and SD. This is a control group self-efficacy. For this, I want to calculate power. So what I have to do, I have to bring this here. Intervention group, this is control group, n is equal to 45, 45. So for mean difference, if I want to calculate power, so click this mean difference in Open API. I think I will take only 1 and 2 minutes, no, but it will take time to open. Always, it will take time. So it is very good software.